at they're called first and second differences. Okay, the keyword here is differences, and what you're trying to do is find the difference of the y values, okay, or the dependent variables. I'm going to highlight it here in red. We're going to find the difference between all of them. So a lot of times they've given you a table in these questions. They'll fill out some numbers, you know, like 2, 1, 0, -1, -2, and they'll tell you, okay, find the differences between these. And this one, and this is actually really good, this question they've asked us to take one of their questions, so they've given us, and we have to fill the table out and then find the first and second differences. So the very first thing we have to do is actually complete this table. And in order to complete this table, what we're going to be doing is we're going to be substituting the x values in for the x and finding out what the that kind of works. I'm going to find out what the y value is going to be in the end. Okay, so for the very first one, we're going to plug the number 0 in. So y is equal to -3 times 0, okay, plus 1. -3 times 0 will give you nothing, and nothing plus 1 is 1. So y is equal to 1. So there's our very first set of coordinates. This is technically a point along this graph. And I'm actually going to just write that point down here, 0, 1. Okay, that's going to be important. That's a point on the graph we're going to have. We'll look at that after. So what we're going to do to fill this out, we're just going to quickly go through these values. So I'm going to do it quickly. That way it's done a little faster. When y is equal to 1, it'll be -3 times 1, which will be -3, plus 1 will give us y equals -2. Okay, so the next coordinate's -2. I need to save space here. I didn't really plan this very well. I'm going to do the rest in my head, but that's essentially the process for this, okay, just to kind of get us through this. So 2 would give us -6, 5, I believe. All right, yeah. The next one, 3, will give us -9, 8, and the next one will give -12, 11. Okay, so those are the values, and each of these is technically a set of coordinates, okay? So just to kind of prove that, let's say negative. Oh, sorry, these should all be negatives. I did miss that. So 1, -2, 1, -2. So there's a coordinate for us. 2, I think it was -5. 3, -8. And finally 4, -11. Okay. So if we kind of take a look at this, it seems to follow what looks like a straight line. Okay, well, we can't say for sure. So what we're going to do is finding the first differences will tell us, when we find first differences, and that's subtracting all of the y values, that will tell us if the equation is linear or not. Now, by looking at this, if you know the rules, because there's no number written here, or we assume it's a 1, we know it's going to be linear, which means the first differences should be the same. Okay, but we're going to go through the process anyway. So we find the first differences. Okay. So we'll start at the bottom and go up because that's going to give us a very important value. So I take -11, and because it's differences, I subtract -8. Okay, it's the same as adding 8. I'm just going to let you know that. So the value here becomes -3. Okay, then we do it to the next set. -8 subtract -5, and that gives us -3 again. -5 subtract -2. Gives us -3 again. And then finally, you can probably guess the pattern. -2 subtract 1 is going to give us -3. So, because the first differences were all the same, that means it has to be a linear equation. Okay, and in fact, because we went from the bottom up, okay, this -3, that's what the slope is. So they've actually told us what the slope of our line is. So if we didn't have the equation, we could figure that out from the table. So we'll put this equation in, -3x plus 1. Let's see, -3x plus 1, and look at that. All of our points fit directly along that line, okay? Okay, so that's for a linear equation. That's for when it's a straight line. The next one is a little more difficult. They've given us, if we know our rules pretty well, because this is the power of 2, this is a quadratic, which means it's going to be a U-shape when we go through, okay? Now, when we're given a table, and again, we're going to have to work our table out the same way that they did here. We're going to, the way we did it above. We're going to have to plug values in for the x and find out what our y values will be. Then we're going to find the first differences, and then we're going to find something called second differences. So I'm going to do this part. I'll do the first one slowly, and then I'm going to try to work through it quickly. So y is equal to 3 times 0 squared, okay, plus 2 times 0. So all we're doing is substituting 0 in for x, minus 1. These zeros pretty much cancel out any number, so you can get y is equal to -1. So here's a coordinate along our line. So let's find another one. 0, -1? Yeah, that's it. 0, -1. So that's for our new thing, okay? For our new quadratic. Okay, the rest of them I'm going to try to do quickly. We're going to get 1. That's going to be 3, and 2 is 5. Minus 1 should be 4. 2 is 4, 12, and 4, 16, 15. These might get hard for me. 3 is 9, 27, and 6, 33, 32. And finally, 4 is 16, times 3, 30, 48, plus 8, 56. I think it's 55. I hope I didn't make a mistake there, okay? But you would just kind of go through that process again. I just want to go through it so we can get to the important part here. So, the very first thing we do is find first differences. You have to do that pretty much every time, and it's always of the y values, okay? The only thing we really have to check with our x values is that they're increasing by the same amount, and we set it up so they're always increasing by 1, so we know that checks it. So we got to find the first differences. So again, we'll take our y values. So 55 subtract 32. That's going to be 15 and 8, 23. That makes sense. 32 minus 15 will be 17. 15, I know I'm doing this fast, but it's essentially just subtraction. You can put it into a calculator and get it. Is 9. And 4 subtract -1 is like addition, so it becomes 5. So we can see that the first differences are not the same by any means. So this is not a linear equation, okay? So we go to the next step. And the next step is to find the second differences. And to find the second differences, you have to have the first differences. So we take these values and subtract them. So 23 subtract 17 is going to give us 6. And is that right? Yeah, 17 subtract 9 is going to give us 8. Oh, no. No, it's not. Yes, it is. So I've made an error somewhere here. And 9 subtract 5 is going to give us 4. I've made a mistake. Shoot. It is that I made a mistake here. I gotta work on my subtraction, my mental subtraction. That's 11. Okay, which means this is the same, but this becomes a little different. This becomes 17, so I'm just gonna erase kind of from here up, okay? These numbers. This becomes 17 subtract 11, which is 6. That's making more sense. Those are the same. And then 11 subtract 5 is going to give us 6. There we go. So now we have second differences that are the same, and that would... Now, the reason I was able to know that was a mistake is because I knew this was quadratic to start. So we were able to go back, and we know the second differences should have been the same there. Okay, so these are second differences, and because they're all the same, that means it's a quadratic, so it has a kind of a quadratic loop to it. So I quickly graphed it here. I'm going to turn all these ones off. We're done with our linear stuff. Okay, so here is our quadratic, and the very first coordinate we put on it was 0, 1, and that's right. What are the other coordinates? 1, 4. So 1, 4 happens on the parabola. So all of these points, 2, 15, they'll all are going to be along the parabola. That's it right there. 32 and 55. Okay, so 32. 3, 32, and 4, 5. And if we zoom out, that's along the parabola, and that's along the parabola. So they all happen to occur along it, okay? So really the goal here, so we'll go over the major ideas again, thank you, is that if first differences are the same, then it's a linear equation, it's a straight line. And if the second differences are the same, it's a quadratic. It has that parabola shape, that U, upside down U, or right side up U. Okay?